Welcome everyone to Data Driven Comedy, the data show where we analyze funny data sets. So, my name is Arben, and today we're going to analyze UFO sightings around the world. So, let's just import the data. All right, let's create a new script. Let's import the tidyverse package. The tidyverse is like a mega package that has a ton of packages in it. It's super awesome. Um, then let's write here a comment. This is going to be the import section of the dataset. And let's go with read CSV. And the datasets of the UFO sightings is called complete.csv. Let's turn that into a table because it's easier to read when it's in when it's in table format. We can store the result in a variable called UFO. All right, so let's explore this data. So essentially, every row represents a sighting. It tells us the state, the country, the shape that it has, etc., etc. What I'm most interested in here is to see the exact location where the UFO has been spotted. So today we're going to work mainly with latitude and longitude. We're going to do some cool geospatial data science. I'm going to focus on the US because everyone knows that aliens love the United States. I mean, if you've ever seen a movie, you know that aliens love to attack the United States. So we're going to get much more data if we focus on the US. So let's go with clean data. And then what we're going to do, first of all, you can see that here we actually have a lot of countries. So we're going to mainly focus on the US. And we're going to apply a filter. We're going to say country equal US, right? And then we also want to make sure that we only want to select the UFOs that have been spotted where there is both a longitude and a latitude. So we're going to remove all the rows that contain an NA value for longitude and latitude. So is an A, yep. In this case, essentially, we're keeping only values that are not an A, but the result is the same. Okay, does that work? Okay, it seems like here we only have the United States, which is perfect. Okay, let's save this result into a variable called UFO US. Perfect. All right, and now what we're going to do is that we're going to load more than install the SF package. SF stands for Simple Feature and is a package used in geospatial data science. Um, in geospatial data science, feature is essentially anything. It can be a tree, it can be a branch, it can be a country. So here, feature is not to be confused with a feature in machine learning, which is essentially just a variable that can be used to explain the dependent variable. All right, so let's import the SF package. And so here, what we're going to do is that, so essentially right now, um, this is just a normal data set, but if we want to do some geospatial data science, we need to turn this into a object that SF can actually understand. So let's do just that. So we're going to apply the function st as sf, and then we're going to take the UFO US file, and then we need to tell to SF what are the columns that need to be used for the longitude and latitude. So in our case, they're simply called longitude and latitude, but that would depend on how your columns have been named. So let's go with latitude, perfect. And then here, there is this argument, which is called CRS, which essentially stands for, I think, I don't remember what it was, to be honest. So let me just give it a look. Up, up, up. So CRS, meaning, I think it was like, so CRS meaning, no, it's not this, geospatial. CRS stands for Coordinate Reference System. Okay, so essentially there are different Essentially, there are different coordinate reference systems. You can think of it like meters, like you have the, I don't know, like the meter system. And then you have the imperial system, which is what is used in the United States or in other countries as well. So here we need to tell to SF essentially what kind of system we're using. And as we're using longitude and latitude, that is the system which is called 4326, if I recall correctly. And essentially that's the system that is used for GPS. And then here, remove false. Okay, perfect. Now let's go to the O. Let's save this in points all. All right, here we're going to say turn UFO US into an SF object for further analysis later. All right, let's go. Okay, there is something wrong here. CRS, it doesn't understand that CRS. Columns. Oh, forgot to close the bracket here. Okay, now let me just check if, okay, here there is an additional bracket. Now it should work. Perfect. And now if we open the points all column, you're going to see that here there is a new column that is used by the SF package, which is essentially a geometry. So a geometry is a spatial object that you can analyze. And in this case, the spatial objects that we're going to analyze are points, right? So it's essentially latitude and longitude and latitude. So that is the geometry. But you can have also, for example, what we're going to do later. We're also going to use counties as geometry. And so county in that case is not a point, is a different kind of geometry. It's called a polygon. Alrighty. Okay, we can just save this already. We can call this simply UFO sightings. Dot R. Perfect. So one thing that we could do is to see how many UFOs have been spotted per state or per county. But the problem with that is that states and counties, they differ in terms of size. And so in order to solve that problem, what we can do is that we can sort of extract a map of the continental USA, and then we can put on top of that map a grid where each square has a size of 100 kilometers per size, right? So you can think of each square being 100 per 100 kilometers. And so we're gonna superpose that grid on top of the continental USA. And for each square, we're going to see how many UFO sightings fall into that square. So let's do just that. So the first thing that we need to do is that we need to change the coordinate reference system because we're going to work in meters, right? We're not going to use longitude and latitude. And the CRS that we have to use, so the meter system is 5070. All right, let's go with that. So now, in order to get a map of the continental USA, we need to import a package, and that package is called our natural Earth, I think. Yep. All right, perfect. And now let's do just that. So import a map of the continental USA. All right. So we should type E states and then country. Here we need to say United States of America. And the class that we want is an SF object because we're going to work with an SF object, as you remember. And then we're going to save this in USA states. So there are a couple of states that we need to exclude, but first let's load the map. Okay, let's open this map. So as you can see here, I think that each row represents a state. And then here we have the name. And if we go right at the end, we should have the geometry. Somewhere there should be the geometry of this. cannot find the geometry, which is strange because it should be an SF. Um, it should be an SF object. All right, let's see. Okay, yeah, you see it's an SF package and it's multi-polygon. It's a multi-polygon because each state is a multi-polygon. But then here, you don't see the geometry for each state, which is strange. Um, I mean, we do have the longitude and latitude, but that was not what I was looking for. Oh, there are more columns actually. That's why. So if we go right at the end, okay. All right, so here you can see the geometry. It's just that this data set has so many different columns. And here essentially this multi-polygon is the shape of each state. But anyway, actually we don't need the geometry here, so it doesn't matter that much, to be honest. Now let's go back and, oops, sorry. Let's go back to the first columns. You can see here, there is a name here. So let's give a look at the names. So we need to exclude, let's put them in alphabetical. Oh, so we need to exclude Alaska because Alaska is not part of the continental US. So filter, all right, then name and, oops, sorry, name and C Alaska. So essentially we're excluding everything so we're excluding Alaska, and this means the opposite, like, so without this, we would be selecting only Alaska. With the exclamation point, we're selecting everything except Alaska. So Alaska is one that we have to exclude. We have Hawaii as well. Let's exclude Hawaii. Okay, let's see if there is something else. I'm not extremely familiar with the United States, to be honest. I mean, with the states of the United States. You know, many Europeans make fun of Americans that don't know European countries. Honestly, I'm pretty lost with American geography, to be honest. Okay, now let's see. We can actually save this now. Perfect. Okay, so now that we have the contiguous United States, we actually need to make it into a contiguous shape because right now it's all separated by states. So let's do just that. So merge all states into a single union. Alrighty. Then we have United States, right? Uh, Sorry about that. So we have United States, and then what we have to do, we need to use the function stunion. So this will create a unique shape, and then we will turn it into a an SF object. I mean, it should already be an SF object, but just to be sure. And then we're going to use the function stTransform, and we're going to make sure that we're using the metric system. All right. Okay, so that works. Perfect. So you can see that we have just one multi-polygon, which is essentially the shape of the contiguous United States. So let's name this variable as contiguous US union. Perfect. All right, let's go. Now, as I mentioned, we want to superpose a grid of squares of 100 kilometers per 100 kilometer. So let's do just that. Let's do just that. So build a square grid and superpose it to the US. So here the cells in meters are going to be 100,000 meters, which is 100 kilometers. If you make it too small, then it's hard to see any differences. And if you make it too small, it may also make your computer bug because there is too much calculation. Now, there is the function that is called stMakeGrid. So essentially what you have to do, you need to take a geometry, in this case, the contiguous US. You need to give the cell size argument. So in this case, it's cells M. And then what are we going to do? We're going to turn that into polygons. So polygons, it's the shape, right? Like here, you can see it's a multi-polygon. And there is the argument squares. And yes, it has to be squares. Now, let's just do this. Perfect. Let's name this grid. Now, ST as SF. Let's turn also the grid into an SF object. Perfect. Grid. I'm not sure if ST_grid returns an SF object by default. Returns. Okay, yeah, it should already be an SF object, as it says here, object of class SFC, but let's do it just to make sure it's all fine. All right, let's see now the value of grid. So as you can see here, we have a list of polygons. Essentially here, each polygon is a square in the contiguous United States. You see that we have 1,363. And now what we're going to do, just to make things easier for later, we're going to add a unique identifier to each square. So let's do this like this. So sequence length and row grid. So this essentially will give us values from 1 to, I don't know, 1,363, if I recall correctly. And that is going to be a new column there. So we're going to add a new column and we're going to call this column cell ID. Okay, perfect. All right, and now if we open grid, now you can see that essentially each square has a unique identifier. Perfect. All right, okay. Okay, so the next step is to join the two data sets. Essentially, we have the grid, right? And then we have the UFO sightings, the dots. So now it's time to see where each UFO sighting falls within the squares of the contiguous US. So let's do just that. So join grid with UFO, oops, UFO sightings. All right. So there is the function that is called stjoin, if I recall correctly. Let's see if I remember stjoin. So we can take the UFOs sightings here, and then here we can get the grid. Then here left equal false. Perfect. Let's see if this works. Okay, we have a problem. Austria. Oh, they have different CRS, different coordinate reference system. So here, the grid, so contiguous union. No, the grid does have the CRSUS, so it's PTS all. Oh, PTS all still has the previous CRS, so the previous coordinate reference system. We're actually going to put that down here because that's where we did it in the script. So ST transform here, PTS all. Oh, sorry, forgot the letter P here. Okay, okay, perfect. Now we should have the correct CRS. You can see here that it's NAD83, which is the same as this 5070. And now if we output grid, you see that it's the same NAD83. And now it should work fully. Okay, it seems like it's working. let's store it into a variable named points in cells. All right. And let's open point in cells. So as you can see here, each row is the UFO sighting, right? And then here we have the point, the exact point where it was seen. And then here we have the cell ID. So this corresponds to which cell in the grid. So each UFO sightings in which cell it falls. So this point falls in onto cell 210. This falls into onto cell 164, etc., etc. So now we have almost everything to to see to see where there are more UFO sightings in which squares of the grid. But right now we simply have the sort of the raw data. Now what we need to do is that um, for each cell we need to count how many UFO sightings there are. So let's do just that. Count how many UFO sightings per cell. Perfect. All right, so we need to take the points in cells variable. Then we need to we can use this. I mean, it's not necessary, but right now we don't really need the geometry, right? So we can just drop it. And then what we can say is group by. I mean, group by it should be by cell ID essentially. Group by cell ID. And then we can reframe and we can call it counts. And so here we are just counting, and then we can simply ungroup. Let's see if this works. Okay. So now, as you can see, for each cell ID, we know how many UFO sightings there have been. So let's save this in a variable called, for example, counts. So now for each cell ID, you can see that we know how many UFOs have been spotted. But one thing that is missing for each cell ID is the shape or where it is located in the contiguous United States. So what we need to do is that we need to join that with the grid, right? Because if we open the grid here, let me open it, grid view. So you can see here that for each cell ID, we do actually have the shape, we have the geometry, we have the actual location, where it's located. So let's join these two together, the counts and the shape. All right, so join UFO counts with cells geometries. All right, so let's do just that. So we can simply do grid, left, join, counts, and it should do it. Okay, yeah, it did it. All right. Perfect. You just see something. Oh, yeah, yeah. Okay, okay. So as you can see, not all cells have a count. Like there are certain areas of the United States where no UFO has been spotted or reported. Let's call this grid counts. Perfect. All right. Okay, now we're ready to visualize the data. Data viz. So let's call this section data viz. I like to use the light theme for my visualizations. Now let's go with grid count. We want to visualize the grid counts, ggplot, and then let's add geosf. So what we're going to do is that we want to fill the map with the counts, right? We want to fill the map with the counts of the different cells. And the color, it doesn't matter, we're gonna type in A. So let's give it a look. Let's see what we get. Okay, so we get this map on the right. It's not a very good looking map, to be honest, but it does give us an idea of where more UFO sightings have been spotted. maybe one thing that we could do, we could try to superpose the US states on top of this map. So let's add another layer to our data visualization. So let's go GeoSF. In this case, we're going to use the USA states as data. Fill, we're not going to add any fill. We're not going to fill it, but we want to differentiate the different states by using the white color and have a line width of 0. Let's try 0.2. Let's give it a look. Okay, so this is a little bit nicer. You can see that a map of the different US states has been superposed to the different squares, which is not that bad. But I don't like this color that much, so maybe we can use another scale, another palette, which is called Viridis. So let's use the Viridis palette. And here we're going to use the C because it's continuous, right? We're working with continuous values such as UFO count. Let's use the magma option, transform SQRT. And then if there are any NA values, let's color them with this gray 95 color. Let's see what this looks like. Okay, so this looks a little bit better. So you see that now this background is in this gray 95 color, and now we can see the differences a little bit better. And now you can see here that we still have the CRS system, the coordinate reference system of longitude and latitude, and maybe we can just remove that chord CRS. We can use the metric system like we want to. Oh, it's still that system. Okay, it doesn't really matter actually. Okay, counts. Uh, Now, actually, we can try to make this a little bit better, but still, I don't know. I don't like to see longitude and latitude, so maybe we can just remove that. So x equal this, y equal this. Let's see. Huh, we still have longitude and latitude. Okay, I'm really not sure how to remove that, to be honest. Um, um, all right, maybe one thing that we can do is that we can actually Google it. Okay, GeoSF, remove longitude, remove coordinates. Okay, let's see how you do that. Color. Okay, it should be this one here. Axis text element dot blank. Okay, let's try this. Let's go with theme. Axis text element dot blank. Yes, it worked. So we were able to remove the X. I didn't know that, so that's great. Okay, but now let's try to make this visualization a little bit better before we start analyzing it. So labs, so the fill, it's going to be UFO sightings. All right. UFO sightings. Okay, perfect. Now let's give a title to this visualization. Title. So the title is going to be, I don't know, UFO sightings per 100 kilometers squares or cells per 100-kilometer grid. I'm not really sure what title to give. And here, caption. I usually put my name as a caption, author Arben Chiku, my last name. Okay, look, this looks pretty good, to be honest. Okay, so what can we see? It does seem that the majority of UFO sightings are on the like on the coast, right? We can see there are a lot here in these areas here, and then there are a lot of sightings here as well, right? So it does seem that aliens actually love the beach. So maybe a subtitle that we can give is Aliens Love the Beach. Okay. Let's see if it works. Okay, UFO sightings per 100-kilometer grid. Yeah, I think we can keep it this way. What title could we give? UFO sightings per 100-kilometer grid squares. UFO sightings in a grid of 100-kilometer squares. Yeah. Yeah, I don't know. Yeah, but it's still understandable. Yeah, it does seem there are a lot of UFO sightings on the coasts. Yeah. But also one thing that I know, for example, you can see here in this part of the coast, there aren't that many, I don't know, there aren't that many sightings, but there are a lot here. And here I think it's New York, so it's probably a much more populated area. Um, and here as well, I think that here I think this is California, and it's possible so that in areas, it's possible that there are more UFO sightings in areas that are more populated. So maybe one thing that we could analyze is UFOs per capita, right? So we would divide sort of UFO counts. We would divide UFO sightings by the population size so that we would get sort of like a UFO per capita indicator. And we can see where aliens really like to go. Yeah, maybe we can do that next. All right. So now one thing that we can do is that we can save this visualization. So we can call it UFO sightings with 100-kilometer dot PNG. Then we can say something like, I don't know, the width. So that we can say that the width is something like, I don't know, 1200. I think it's pixels probably by default. And then height, we can say something like 800 and resolution can be 110. All right, now let's close the canvas. So now it should be here. Oh yeah, right. So we can see that the UFO sightings file is now here. So let's open it. Yeah, wow, this looks pretty cool. Looks pretty neat actually. All right, awesome.